Hello students, this is Mr. Nguyen. Today I am going to show you a few tricks on solving systems using the elimination method, okay? Before we start with the Excel examples, I want to recap what the elimination method is all about. Okay, so the main thing about the elimination method is we try to either add or subtract the equations to eliminate one of the variables, okay? So here are a few things we need to keep in mind is that we need to keep the equations lined up vertically. So x lined up with x, y lined up with y, and the constants line up with the constants. It really doesn't matter what form they're in. As long as they are lined up, then we can use elimination, okay? If the variables are already opposite, then we add them. If they are not opposite, then we subtract them, okay, to make sure we eliminate them. And we always want to make sure that the variables have the same coefficients, okay? So I have multiple ways to do elimination. So because the problems could appear to you in multiple forms, right? So like you see example here, the plus 3y and the minus 3y, if you add them, they will give you 0y, which means you just eliminated that y variable, right? And then we could solve for x, and then we take the solution, we plug it back in, blah, 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 okay? So let's get to the first example here. All right, so here you see this system already have the y variable with the same coefficient, and they are opposite. One is minus and one is minus and one is plus. So this is what it means when it says subtract if the variables are the same and then add if the variables are opposite. So because the variables are opposite, we're going to be adding, okay? So we're going to add these two equation. And when I say add the equation, you're adding every single terms together vertically, okay? So we're actually combining the x and the x. So you have to tell yourself it's negative 3x and negative 1x. That will give you negative 4x, okay? You actually have to treat those coefficients with the signs like that. And the y variable is already eliminated. Once you add them, you get 0, right? And now you have to add 7, positive 5 and positive 7 together on the other side of the equal sign, so you get 12, okay? So now you can solve this short equation for x by dividing everything by negative 4. So it's 12 divided by negative 4. This is going to give you the value for x, which is negative 3. And so now after we're done, after we solve for one variable, then it's pretty much what we did before, right? We take this answer and we substitute it back into one of these equations, okay? I usually take the shorter one, the one that looks, I guess, easier. But either way, you know what? Let me take the first equation. It doesn't really matter. Let me take the first equation so that I can show you guys to put this negative 3 in the right spot. Okay, so here's the equation. Negative 3, and then there's an x there, but I don't want to use an x. I want to put a number in there because I already know what x is. So I put the negative 3 in here. Okay, so the negative 3 goes in for x. Okay, it would go in for x. Minus 4y equals 5. Okay, so you can use the second equation also, but you got to watch out. There's a negative and then negative 3. Okay, a lot of people forget it's double negative. This will give you a positive 9. This will give you a negative 4y, and then equals to 5. Then you're going to move this 9 over here by subtracting it. We're solving the equation for y now, okay? That's going to give us, remember to carry this negative down. Oops. Carry this negative sign down. So it's negative 4y equals to negative 4, okay? I think I can type a lot better than I write. It's so cold in my house, I can't really write. So we're going to divide everything by negative 4. So we're going to get y equals to actually positive 1. Okay, so here's our two answers, negative 3 and positive 1. These two answers make up the solution to this system. So we're going to type in negative 3 for x. Make sure you put them into the right spaces. And then y is 1. Submit. Okay, so That's an example of when your equations and the coefficients are the same and the signs were opposite. Now this time the signs are the same. You see this right here? The coefficient for y is the same, but the signs are also the same. So remember, when the signs are the same, we are going to subtract, okay? So the signs are the same, we're going to subtract. Subtract is a little trickier. You got to apply the subtraction to everything, okay? So there you go. So now in your head, you know that the y variable is eliminated. So you can cross that out. But in your head, you got to be very careful. This -4 combined with a minus -x would be -4x plus x. Okay. So it's a positive x because it's minus a negative. So when I combine them, I get -3x. Okay. Equal. And this is 19 minus a -11. So it's kind of like saying 19 plus 11, okay? Because the negative and the minus makes the number positive. So here we're going to have 30, okay? And then after this, it's really just smooth sailing. Dividing by -3, you get x equal to -10, okay? And then once again, we take the answer and we substitute it back in here. I think this time I'm going to use the second equation, just to let you guys see that you have to be careful here. The equation already has a negative, okay? And then the parentheses for the x value. Well, the x value is actually a -10 also, so we actually have to substitute the -10 in there, okay? So be careful, there are two negatives here, okay? -7y equals to -11. -11, okay? So now this thing turned out to be 10, okay? So when you move the 10 over here to the other side, it's going to be minus, okay? So technically you have -7y equals to -21 because you have -11 and -10 combined, okay? So that's going to give you -21, okay? And so now you're going to divide. You're going to divide both sides by -7. Well, when you do that, negative divided by negative will give you a positive answer. So y happened to be 3. 21 divided by 7, or -21 divided by -7. So our answer is 3 for y, and -10 for x. Okay, so I'm going to type in the x value first, which is -10. Okay. These two examples that I have done here are considered the easy examples, really. Okay. I'm going to skip along a little bit to let you guys see a little bit harder example. Okay, I think this one is not hard, but it's different. Okay, it's different than what we've done. Okay, so again, we want the coefficients to match. Okay, right now we don't have anything. The x coefficients don't match, the y coefficients don't match. Okay, to make them match, we have to multiply either one or both equations with some numbers that they have in common. Okay, so as you can see here, the x variable are already opposite signs. Okay, this is a negative here and a positive here. The y variable is also opposite sign. Okay, so you have two choices here. You can multiply the first equation by 2. That way you get -2x, and then when you combine with a positive 2x, the x goes away. Okay, or your other choice here is to multiply the second equation by 2. When you do that, the y variable will become -4y, right? Because we multiply by 2 with everything. So the y variable become -4y. And so the y will go away. So you have two choices. Either way you do it, it's fine. It's going to give you the same answer, whichever you prefer. I will probably just go ahead and get rid of x first. So multiply this equation by 2. So it turned out that I'm going to type. I think I can type in faster. I don't know. No, I'm going to have -2x. I cannot make up my mind. -2x plus, be careful here, we have to multiply this 2 with everything inside, okay? Everything. So this would turn out to be 8y. So essentially you are doubling the equation, okay? Equals to 40. You're doubling the equation by multiplying it by 2. The second equation is exactly the same because I didn't do anything to it. And I don't want to do anything to it because if I do something to it, the numbers will be different again, right? So I want to keep it the same. That way I can eliminate this. So am I adding or subtracting? Well, they're opposite, so all I have to do is add. Because if I add the opposite, they will go away. Okay, so now I'm adding them. Okay, what do I have here? Positive 8 and negative 2 will give me positive 6. Why? And then positive 40 and negative 40 give me positive 36. Divided by 6, I get y equals to 6. Okay, so when y equals to 6, I can take it back in here and plug it back in here. I think I'm going to use the second equation. I'm going to use the second equation to solve for x because I already have y. Okay, so my equation is 2x. I'm not substituting the x because I'm looking for it. Minus 2. I am substituting for the y because I already know what it is. It's 6 equals negative 4. Okay, that's my second equation. And then I'm going to work out this equation. I'm going to move up here because I'm running out of room. This is going to be 2x minus 12 equals negative 4. Okay, and that is going to give me 2x equals okay, I'm going to move this over here. So it's going to be negative 4 plus 12. And then I'm going to simplify that. Okay, 2x equals what's negative 4 and positive 12? I believe that is positive 8. And then I divide by 2, I get x equals to 4. Okay, I divide by 2, I get x equal to 4. Okay, so here let's check out what our solutions are. Here's one answer. Here is the other answer. So our solution is actually 4 comma 6. Okay, so this is a different type of problem where you actually have to change one of your equations so that the coefficients match. Okay, submit. Perfect. Okay, here we don't have, this is the same example as example 2. So these are the same coefficients, the same, signs the same, so we're going to subtract, right? So I'm not going to do that one. If you want to see this method, you look at example 2 that I just did. Okay, I am going to skip jump level to see if we get things that are more interesting. Okay, this one is a little interesting, so I'm going to work this one out. So this one, you have two choices again. You can multiply the bottom equation by a negative 3. Why? Because I want it to match the coefficient with the top variable for x, and I also want it to be opposite. Okay, now if you don't like negatives, then don't multiply by negative 3. Multiply it by positive 2. Why? Because 2 times 2 will give me positive 4y. And that's going to cancel with the negative 4y. That way I don't have to worry about the negative side, right? But here I want to look at the second equation and I want it to match the top equation, okay? And I have two ways to do that. All right, so the top equation stays the same. It's so cold in my house. The heater's been running, but it is not warm enough yet because it's so cold outside. All right, and I'm hoping that the power doesn't go out in the middle of this. So now remember, multiply 2 through everything. 2 times x, 2 times 2, 2 times 8. Okay, so this is going to be 2x. This is going to be positive 4y. As you can see, those will be canceled. And then positive 16. I almost made a mistake there. Okay, now I'm going to add them, right? I'm adding because this is opposite. So I'm adding to get rid of them. And now I'm gonna have 5x equals 30, I think. 16 plus 14 is 30. And then divided by 5, x is equal to 6, okay? So now take one of these equations. Doesn't matter. I think I'm going to take the second one. It looks shorter. So I'm going to have 6 plus, so take the original equation, okay? Not the one that you doubled up, okay? The original equation is shorter. 2y equals 8. Okay, so I'm substituting the 6 in for this x here, okay? Move the 6 away by subtracting it. So I'm going to subtract 6. So I have 2y equals 2. So y is equal to 1. Dividing both sides by 2, okay? So I'm going to type in my solution. X is 6, y is 1. X is 6, Y is 1. Okay, submit. Perfect. All right, this is the case where you can multiply the bottom equation by 6, and that's going to get rid of x. Okay, so I'm going to skip this level. This is the case where it's a little different here. Okay, if you look, I cannot just multiply by one equation. I have to multiply by both equations, because what am I going to multiply by 4 to get 7? Nothing. What am I going to multiply by 7 to get 10? Nothing. Okay, nothing nice, at least. Okay, and I certainly don't want to multiply by a fraction. That's going to make a mess. So if you look, and then of course, uh, I can't multiply anything by 7 to get 4. So this is the consider the hard case, where you actually have to multiply both equations by some numbers, so that you can turn either the x the same or the y the same. Okay, so if you look at 10 and -7, well, to make them the same, you can make them both 70. Right, you can make them both 70. So I can multiply the top equation by 7 and the bottom equation by 10. That way, I can multiply the equation by whatever numbers I want, because I'm multiplying everything evenly, right? So I haven't changed the math yet. I changed the number, but I haven't changed the math yet. The equation is still balanced. So I can multiply the equations by what number I want, but the numbers are very carefully chosen for a specific purpose here. I chose 7 so that I get 70x. I chose 10 so that I get negative 70x. That way they're opposite, so I can eliminate. Okay, so what happened when I multiply the first equation by 7? Well, let's work out the math here. I get 70x. This is my last example because this is considered the hardest case scenario. So 70x minus 7 times 7 is 49y. So this is where, if student makes mistakes, this is where they make mistakes. Okay, they didn't multiply the 7 through. And then equals to 7 times 7 is 49 again. Okay, so I pretty much made the first line 7 times thicker. That's all I did. Okay, I'm going to make the second line 10 times thicker by multiplying everything by 10. So 10 times -7 is -70x. Okay, 10 times 4 is positive 40y. Okay, positive 40y. And then 10 times -13 is a negative 130. All I do is, oops, sorry, that's 3. It's not good. All I do is add a 0. Okay, so now I combine them by adding, because they're opposites. So the x will go away. I'm adding these. So -40 and positive, -49 and positive 40 will give me a -9y. Okay, -9y equals, there's no shame in using your calculator if the numbers get too big. Okay, so like here, see, 10 minus 9 is 1. I'm combining a positive and a negative. My answer will be a negative, but whatever that's left over, right? So negative, what is it? 13, 12, 8, 81? No, 81. Let me see. Yeah, 81. And so I divide both sides by -9. So -81 divided by -9 will give me +9. Okay, because it's negative divided by negative. So you guys, when you guys are doing these problems and the numbers get messy and there's negative everywhere, just slow down, take your time, and make sure that you get the correct answer when you're dividing or subtracting or whatnot. Because just one wrong sign anywhere in your problem, then the whole thing is wrong. Okay. All right. Now that I found the y value is 9, I'm going to take one of my original problem. It doesn't matter which one. I'm going to take the first one. Okay. Sorry for the arrows. I just want to know you guys to follow along what I'm doing here. So here's the first equation, 10x. Okay, I already found y. I need to find out what x is. Minus 7 times y. Well, y is 9, so I'm going to put 9 in here. Equals 7. Okay, that's my original first equation. Now I'm going to work out the math here. That's going to be 10x minus 63. 7 times 9 is 63. Equals 7. Okay, Now I'm going to add 63 to this side because I'm moving it to the other side, right? So I'm going to add 63, okay? You guys have done this so many times, so I hope you remember that. Okay, so add 63. That's going to make, what is that? That's going to make 70. 63 plus 7 is 70. So I have 10x equals 70. And if you are ahead of me, you already know x is going to be 7 because you divide by 10, right? So 70 divided by 10 is 7. So I get two answers here. That is my solution to this system. And guys, if you can do this problem, it's going to make my previous examples irrelevant. Because if you can do this problem, then you must have already understood what to do with the other problems, okay? So try to do these kind of problems. If you can do the hard ones, then the easy one, of course, you can do. 7, 9. Now, algebra mistakes, anybody can make, even me, right? So just be careful. Anybody can make mistakes with the algebra. But the method, not everybody can do. So hopefully you guys understand what to do and try your best when you guys are doing this. Remember, take your time. Okay, I'm going to stop here because I've shown you pretty much all the possibilities of these type of problems. Okay, so have fun, play with it. Let me know how it goes. Send me questions if you have any questions or get stuck. Thank you for watching, you guys. I will see you next time. Bye bye.